students, welcome to my channel, Crack Physics with Anisha. Let's make physics concepts simple, fun and clear. Moving to the next question. An electric heater consists of three similar heating elements A, B and C connected as shown in the figure above. Each heating element is rated as 1.2 kilowatt to 40 volt and has constant resistance. S1, S2 and S3 are respective switches. The circuit is connected to a 240 volt supply. First question, calculate the resistance of one heating element. Calculate the current in each resistor when only S1 and S3 are closed. Calculate the power dissipated across A when S1, S2 and S3 are closed. So first part of the question, before answering that we can check what all data are given in the question. So we have three heating elements, all are similar in nature means they're heating elements. That means the conductor is made up of same material. They have same resistance and they are rated as 1.2 kilowatt and 240 volt. So power is given as 1.2 kilowatt and they work with a voltage of 240 volt. And S1, S2, S3, three switches are there and the input power supply is also given, it is 240 volt. So definitely all these elements can work with this input voltage. Now we have to find the resistance of one of the heating element. We know A, B and C all have same resistances. So if you find the resistance of any one of these, we will get the resistance of the heating element. So same only. So here A and B, these two components are in series. So definitely their voltage value will be different because they are in series combination. But when we consider the element C, that C is connected in a parallel combination with the input voltage. So the element C will be definitely getting 240 volt as the potential difference and its power also we know. So we can substitute in the relation of power P is equal to V square by R to find the resistance of the element. Anyways, the same resistance is obtained for A and B also. Yes, so R is equal to V square by P and V is already given, that is 240 square and P is 1.2 kilowatt. You can convert that into watt by multiplying with 1000. Once you solve it, you will be getting the resistance as 48 omega and this calculation part is very easy. You can do it by yourself. So that's about the first part of the question. Now, this is the resistance of all the elements A, B and C. All of them have 48 omega of resistance. Now, the second part of the question. Calculate the current in each resistor when only S1 and S3 are closed. When S1 and S3 are closed, so I'll just show you how the figure comes. Only S1 and S3 are closed. S2 is open. That means no current will pass through S2. There is no current flow through S2. So what will be the corresponding figure? If you just try it by yourself, you can, I'll just draw the figure once. So it would come something like this. We can consider we have our A, B, and S1 is closed. So I'm writing it as S1. Yes, there is no S2 because it is open already. So we are not considering that. We have C and S2 is also closed. So it comes something like this, isn't it? And this is 240 volt. I'm sorry, it's not coming. Okay, 240 volts. It's not coming. Something happened there. Okay, fine. So in this figure, we have to find out the current in each resistor. So how much current passes through A, B and C. So just imagine that if I current passes through the circuit, the total current in the circuit is I, as AB is parallel to the input voltage, C is also parallel to both AB and input voltage. The current will split up once it reaches this junction. So we can imagine let I1 current passes through this point and let I2 current passes through this point. Okay, at this junction. So we can say I2 current passes through C and I1 current passes through A as well as B because they are in series. So how we'll find it? So it's very easy to find the I2 current. Why? Because I2 current we can find using voltage and resistance value. We know voltage is 240 volt here because the resistance C is in parallel to the input voltage. Its resistance we already found it as 48 omega. So what is current? According to Ohm's law, I is equal to V by R. Here we are finding I2, so we can write I2 is equal to V by R, and that is equal to 240 by 48, and that is equal to 5 ampere when you do the calculations. Yes. Now, I1 current is same for A as well as B as they are in series. So we have to find I1 current. So in order to find I1 current, again we can use the Ohm's law V by R. So here the total potential difference across A and B, we know it would be 240 volt because A and B together is in parallel combination. So voltage, okay, you can take it as 240 volt for across A and B, and the resistance we have to take the effective resistance of A and B together, isn't it? Yes. So that effective resistance we know as they are in series, Rs could be found by using the relation R1 plus R2. Yes, that is Rs is equal to R1 is 48 and R2 is also 48 because they are similar. That is equal to 96 omega is the effective resistance of A and B. So how much is I1 current? I1 is equal to 240 by 96, not 98, it is 96. So that is 240 by 96, we'll be getting 2.5 ampere current. So that means IA is also equal to 2.5 ampere and IB is also equal to 2.5 ampere because they are in series connection. Now comes the third part of the question. In third part of the question, we have to calculate the power dissipated across A when S1, S2 and S3 are closed. All the switches are closed, S1, S2 and S3. So our figure becomes like this. Let's just redraw it. Yeah. S2 is also closed. So what will be the power dissipated? Now in the question it is already given that the power dissipated across each element is 1.2 kilowatt. So definitely we get the power dissipated at A is equal to 1.2 kilowatt. Or we can say, yes, in watts we can say 1200 watts. No problem. But we can calculate this. How we can calculate it? So just check the diagram. We know that if this is the input voltage, yes, the current is passing through this particular connection, I current is passing through it, and the same current, it passes through this branch as well as this branch also. So when the current is passing through this branch, we can see that the connection positive terminal from here, the connection starts and then passing through this branch of S2, you can see that this element A is like a parallel connection to the input source. Isn't it? When S2 is closed, the resistor A is like in parallel combination to the input source. So the voltage across A can be taken as 240 volt. Now we know its resistance is already 48 omega. Yes, now using the relation what? Power is equal to V square by R. Can't we find the power of A? It is 240 square by 48 and that will be equal to 1.2 kilowatt. You just check by yourself, it will be same only. So anyways, in the question it is given, but still we can calculate it. If it is not given, we can calculate it. So that's about this question. Next question. First, we'll answer the first part of the question. Explain why in household circuits only the fuse is connected in series with all the rest of the appliances, but all the appliances are connected in parallel to each other. So when we consider the domestic electric circuits, all the appliances are connected in parallel. The reason is when we connect the appliances in parallel, all the appliances will get equal voltage. So we know when we consider when two resistors are connected in parallel to an input source voltage, if V volt is supplied, the voltage available to both the components will be same. The potential difference across both the components will be same. But the current, what happens to the current? The current will split up because they have two different paths to flow. So current splits up and current will be different for each component. So the first reason why we connect the domestic appliances in parallel connection, equal voltage is available to all the appliances. That is the first point. Second point is that if any one of the appliance damages, it will not affect the other one. Why? Because current has a different path to flow. So the damaged appliance will not allow the current to pass through that particular connection, but the current can flow through the other paths. So it will not affect the other components. So when we are connecting the appliances in parallel, when one component damages, it will not affect others. It won't affect other components. That is the reason why we are connecting the devices or the electrical appliances in parallel. But in the case of fuse, the main function of fuse is it acts as a safety device. It saves the components from excessively increased, or we can say excessive current flow. So we know that when excessive current flow happens, which is beyond the limit of that particular appliance, the appliance will damages. So in order to avoid such a situation due to some voltage fluctuation or any other reason, excessive current flow can happen. So in order to avoid such a situation, in order to stop the current to flow to that particular appliance, the fuse wire has to break the circuit there. So if we connect fuse wire in parallel, it will not affect the appliances because the path in which the fuse wire is connected only will be blocked. It will be only breaking. So if we connect the fuse wire in series with the whole domestic appliances, what happens is that the particular fuse wire will be blocking the current flow. So from here, if this is the fuse wire connected in series, these are the different components, and from here there is an input voltage given. Due to the voltage fluctuations, if there is high current passing through the particular conducting line due to the low melting point of fuse wire, according to Joule's law of heating, this fuse wire will melt and break the circuit and save the other devices from getting damaged. But if we are connecting the fuse wire in parallel, what will happen? Yes, it won't affect the other devices. This particular line in which the fuse wire is connected, that only will discontinue the current flow. Current will flow through the other paths. Means it will pass through the other appliances, which will cause damage for the appliance. So that's why we are always connecting safety fuse in series with the domestic circuits. Next question. In household circuit, an electric heater of power 1500 watt and a fan of power 500 watt are connected in parallel to a 220 volt supply. A fuse rated for 10 ampere is connected to the circuit to protect it from excessive current. Calculate the total current drawn by the heater and the fan. Determine whether the 10 ampere fuse is appropriate for this circuit or if it will blow. So for that, first part of the question, we have to find the total current drawn by the electric heater and the fan. First of all, we can write down the data. So the power of the heater is given. So I am writing it as PH. It is 1500 watt. Power of fan is also given. PF, we can write it as 500 watt. And both of them are connected in parallel to a voltage source of 240 volt. Now we have the fuse wire, and the fuse wire can carry the current maximum. It can withstand the current of 10 ampere. That's what it is given. The fuse wire is rated for 10 ampere, means it can withstand the current till 10 ampere. So if the current is above 10 ampere, the fuse wire will melt and it will break the circuit. Now, the first part of the question is to calculate the total current drawn by the heater and the fan together. So total current drawn by the heater and the fan together means we have to find the total current in the circuit. Isn't it? Yes, we have to find the total current in the circuit. Now, how we'll find the total current in the circuit? So if this is the heater and this is the fan, how we'll find the total current? We have the input voltage. In order to find the total current, we can see the current will split up when it reaches the junction. IH current passes through the heater and IF current passes through the fan. Because it is a parallel connection, current will be different because it has two paths to flow. So first of all, we can find how much is the current flowing through heater as well as the current flowing through fan, and then you can take the sum. So we'll get the total current in the circuit. So in order to find the current flowing through the heater, IH, what we'll do? We have our power value, we have our voltage value, and voltage will be same for the heater and the fan because they are parallel combination. Yes, so we can use the relation P is equal to V into I to find the current. So IH is equal to PH by V, that is equal to PH, it is 1500 divided by 240. I'm sorry, it is not 240, it is 220. That was my mistake. You have to take voltage as 220. We know it is a domestic electric circuit. We can use only 220. Yes, 220. So how much will be this? 150 by 22 will be getting 6.82 ampere current passing through the heater. Likewise, we can find the current passing through the fan, that is PF by V, power of fan to the input voltage, and that is 500 by 220. Cancel it out, 50 by 22, again you will be getting 2.27 ampere. Now the total current drawn by the heater and the fan means the total circuit current, that is IH plus IF. You take the sum of 6.82 plus 2.27, you will get 9.09 ampere. So this is the total current flowing through the circuit drawn by the heater and fan together. Now moving to the second part, we have to determine whether the 10 ampere fuse is appropriate for the circuit or it will blow. Definitely a 10 ampere fuse is appropriate. Why? It is appropriate because the total current that drawn by the both the components are 9.09 ampere only. So if a current greater than 10 ampere passes through it, definitely we can say both the appliances will break down. Both the appliances will get damaged. So it is the function of the fuse to save these appliances from getting damaged. The fuse wire will melt once a current greater than 10 ampere passes through it. So we need 9.09 ampere of current. So definitely a 10 ampere fuse is appropriate. So this is correct to use a 10 ampere fuse in this particular circuit. It will not blow the circuit. Next question. The two resistors R1 6 ohms and R2 12 ohms are connected in parallel to a 24-volt battery. The circuit operates for 5 minutes. First question, calculate the total heat generated in both the resistors. Second, if each resistor has a power rating of 100 watt, determine whether it is safe to use these resistors in the circuit. So first of all, we can write down what all data are given. R1 is given as 6 omega and R2 is given as 12 omega. Yes. And the voltage is given as 24 volt and the time of operating the circuit is 5 minutes. Now, first question is to calculate the heat generated by both the resistors together. They are connected in parallel also. It is also given, okay. So together, how much heat will be generated by these resistors? So the equation to find the heat generated by the components is using Joule's law, H is equal to I square RT. I is the current flowing through the components, R is the resistance, and T is the time of flow of current. Now here we don't know how much is the total current passing through the circuit. So first of all we have to find the I value. Resistance is given. This resistance we have to take the effective resistance because two resistors are there. So we have to take the effective resistance as they are in parallel. We have to find it first. And time is given, but this is in minutes. So don't forget to convert time to second. So how we'll find all these values? In order to find the current, we need total voltage by the resistance value, and that is Rp. Again, we need the resistance value. So in order to find Rp, we can take, there are only two components. So we have to write the equation for effective resistance. 1 by Rp is equal to 1 by R1 plus 1 by R2. That is 1 by Rp is equal to 1 by 6 plus 1 by 12. When you take Rp, it will be 6 into 12 by 6 plus 12. That would be 72 by 18, and that is 4 omega. So 4 omega is the total resistance of this particular circuit. And now we can find the total current. How much will be the total current? Total current I will be equal to V by Rp. So that is 240 by, yes, it is given as 24, not 240 volt, it is 24 volt. So it would be 24 by Rp value, it is 4. So that would be 6 ampere. So the total current passing through the circuit is 6 ampere. Now we can substitute all the values. Before that, don't forget to convert the time also. It is 5 minutes. So converting 5 minutes to seconds, we know 5 into 60, that is equal to 300 seconds. Now we got all the values. So substitute in the relation of Joule's law, H is equal to I square. I square means it is 6 square into R, that is 4 omega, into T, that is 300. That is 36 into 4 into 300. That is 36 into 1200, and we'll be getting 43200 joule. Now if you have to convert this into kilo, this is the answer. If you have to convert it into kilojoule, you can just divide it by 1000. So we'll be getting 43.2 kilojoule of heat energy is produced here. That's it. Next part of the question. If each resistor has a power rating of 100 watt, determine whether it is safe to use these resistors in the circuit. So here the resistances are given. R1 is given as 6 omega, R2 is given as 12 omega, and the operating voltage is given as 24 volt, and they are connected in parallel. Now, if each resistor has a power rating of 100 watt, is it safe to use these resistors? So first of all, power rating is given. That means the maximum power dissipated by these particular resistors are given. So are they safe to use? So we can find the power dissipated by these resistors individually first and check whether it is safe to use or not. So for R1, the power dissipated, how we'll find the power dissipated? We know power P is equal to, there is a relation V square by R, isn't it? Yes. Now these resistors are in parallel, so voltage will be same. The power value we have to find for R1. So P1 is equal to V square by R1, that is equal to V square means it is 24 square by R1 value is 6, and we'll get it as 576 by 6, and that is equal to 96 watt. And for R2, the power dissipated, the actual power dissipation is given as P2 equals V square by R2, and that is 24 square by 12, and we'll be getting 48 watt. Yes, we'll be getting 48 watt. Now, when we observe these power values of R1 and R2, both are below 100 watt. As they are below 100 watt, we can say that these two resistors are safe to use. The power dissipation is below 100 watt. So it is safe to use in this particular circuit. Thanks for watching. Subscribe for more videos, hit the bell icon and join our learning journey.